the long title is Boosting the Industrial Uptake of Biodegradable Polymers for Packaging Applications by Implementing Digital Tools and Advanced Techniques to Achieve a Holistic Sustainability Goal. Okay, so first of all, I want to mention that the BIA project has been funded by the call Biodegradable Polymers for Sustainable Packaging Materials. And I want to remark that this is an innovation action. So we expect to achieve at least a TRL 7, around 7, at the end of the project. BIA project will be implemented by a well-balanced partnership that covers all the necessary competences to deliver the project objectives as it is shown in the figure, okay? The consortium is composed of 17 partners. We are 4 RTOs university, 2 associations, 1 standardization body, and 5 SMEs and 5 industries. And we work from 9 European countries, different countries. So we, as ITENE, are the coordinators. We have a track record of several projects coordinated, around 17, I think, in Horizon 2020 and Horizon Europe projects. And BIA project is going to work, as you could see here, along all the value chain of the packaging. As you could see, we are going to start with the synthesis part of novel biopolyesters. We have here Novamont partner working with University of Trieste and Hybrid Catalyst. And we are going to continue with the formulation of novel packaging materials led by ITENE with the collaboration also with Novamont, University of Trieste, Imeris for the mineral additives and FTPO. And as I have mentioned before, this is an innovation action. So industrial partners are key actors. And we have here Uptake and Inotec scaling up the packaging production processes, Uptake for the injection molding part, and Inotec for the flexible film and rigid sheet extrusion and thermoforming. Key aspect that I think that differentiates BIA project from other projects is the predictive modeling of the different processes that are going to be involved, from the synthesis, the formulation and compounding, and also the packaging production and the biodegradability. And we have here ETENE partner and Polynivo partner. And also the biodegradability assessment. We have TEBIMAT in the biodegradation in open and real environments, and also we have NORMEC for the controlled lab conditions. And all this work is going to be developed in the frame of the safety and the sustainability, having here particular ITENE working on this. And also we are going to work in the labeling and standard part. We have UNE. And the circular business models, we have Isotech, and dissemination and communication, and also the stakeholder engagement. And we have here European bioplastics and Polymers and FTPO working on that. So let me just first speak a little bit about why we have drafted this BIA project. As you could see here, and I think you already know, the bioplastic market is experiencing a dynamic growth, okay? And BIA project, the main strategies underlying by the BIA project are, as you can see here, we are going to work very aligned with the EU circular economy strategy, the European strategy for plastics in the circular economy. We also are going to work directly aligned with the European Green Deal by contributing to the fight against this plastic pollution, okay? And also we are going to work aligned with this packaging and packaging waste regulation, designing recyclable materials to support these EU proposals for this PPWR. Okay, just a little bit more. What are the main market challenges for the bioplastics? We have, for example, the market penetration. So packaging market remains the largest market sector for the bioplastics, representing a 43%, with a forecast to grow by 15%. So it's a very huge market penetration sector. We need to demonstrate this technical and economic feasibility or viability, let's say, of these bioplastics to increase and to achieve this economic scale of these materials, and trying to achieve huge market penetration, let's say. Also, we need to tackle these drawbacks in terms of technical features of the biopolymers that we have right now in the market. So we need to improve the technical performance and to introduce these materials in novel packaging applications. And also another challenge is, of course, to demonstrate the safety and the sustainability of these novel materials, these novel biomaterials that we are going to develop. So, okay, which is the general objective of the BR project? We are going to work and we are going to develop and demonstrate novel biodegradable and recyclable formulations in order to obtain sustainable packaging materials. Which is the goal? The goal is to replace the actual fossil-based PE, PP, and PET materials, packaging materials. And also we work to improve, and not only replace, we work to improve the sustainability of these materials. And we have the goal of reducing up to 40% the GHG emissions by using efficient processes and guaranteeing also, of course, the safety. Okay, so as you could see in the picture, we are going to move from these fossil-based materials that are not sustainable at all, and we are going to work enhancing the bioplastic biodegradability and performance of these novel materials, starting from the synthesis, working with the formulation of the materials, scaling up and just demonstrating the feasibility, the scale up feasibility of these novel materials for common processes. As you could see later on, you will see that the common techniques, processing techniques that we are going to work with. And don't losing the biodegradation assessment of the materials. So, and all this work, as I commented before, is going to be assisted by the predictive modeling of the different processes and also with the safe and sustainable by design perspective. So let me go a little bit deeper in each step of the value chain, okay? So in the first step, we are going to work in the polymerization in the biopolymer development. So from the polymerization step, we are going to apply innovative performing and non-toxic sustainable novel titanate catalyst to produce these novel bio-based polyesters. Okay. We are going also to work with biodegradable, we want also to increase the bio-based part of these novel biopolyesters. So we are going to work with bio-based building blocks. And also we are going to use, as I said before, I think this is a differentiation that marks this BR project. We are going to use model-based macromolecular design. These modeling techniques and Monte Carlo kinetic models in order to improve or enhance this polymerization step. From the material formulation, after that we are going to use this novel biopolyester obtained with this polymerization step, and we are going to go through the compounding step, the material formulation, using biobased and high performance additives like biobased chain extenders and mineral fillers. And also we are going to use in this step these advanced simulation and modeling techniques for the formulation step also. And we are aimed to reduce the operational time, because we are going to use also not only the simulation tools, we are going to use inline monitoring techniques in order to improve these steps of characterization in the development. And inline, we are going to be able to measure important properties like rheology properties and so on. And we are going to improve these operational times. And as I said before, as innovation action, an important step is to demonstrate the prototype production and the scale up of these processes. So we are going to work with the main processing techniques in the packaging sector. As you could see here, we are going to work blow film extrusion, cast film extrusion and thermoforming, and also the injection molding. Another important aspect is the biodegradation assessment, okay? The implementation of the different biodegradation tests under, as I said, both controlled laboratory conditions according all the international standards, and also in real conditions, both in controlled and also in open environments, will enable the BR project to establish correlations between these measurements and the standards, okay? So which is going to happen to these novel biodegradable materials in real cases, and the correlation between the standard test that we have now. These correlations will be at most interest in predicting the lifetime of these novel materials and at the real rate of biodegradable products at the end of life selected. Also, we are going to work in the modeling part for the biodegradation part, okay? So we are going to develop the biodegradation modeling tools, which will make accessible to involved stakeholders through an innovative BIAP platform that we are going to develop. So this online BIAP platform, it's going to be able to analyze this gap between the standard, the lab conditions and the real environment conditions. And this innovative platform will enable the stakeholders to choose or to really choose an exactly or the better or the most suitable end of life for the different materials and packaging materials. Okay, and the last step will be the standardization. BIA project will enhance the improvement of the standardization of this biodegradation test and labeling of materials of the different packaging products that we are going to develop based on this new knowledge that we are going to obtain from the test, from the biodegradation test in, for example, open environments, and the assessment and the modeling of the biodegradation pathways. Also, we are going to work in recommendations for labeling, and we are going to provide information about the composition and the appropriate use and disposal of the developed materials in the project. These recommendations will be shared with policymakers and standardization bodies and certification agencies. And also, we are going to ensure that broad stakeholder involvement in this advancing sustainable practice are going to be achieved.